All right, it might be best to go through the levels of measurement by looking at some examples. So by looking at these examples, we'll go over the level of measurements. Okay, Taos, Acoma, and Zuni and Cochiti are the names of four Native American pueblos and the population names from all Native American pueblos in Arizona and New Mexico. And so what level of measurement is this? Well, we call this the nominal level of measurement. Okay, nominal. Okay, and so basically they're simply names here. Okay, and so they're names and basically we cannot make comparisons. So these names they group they put a groups into groups by their names, but they we can't really make comparisons between the groups based on the name. So it'd almost be like I want to know the majors of students at a college. And so majors of college, grouping them by their major would be a nominal level of measurement. I can't really make any kind of comparisons, but what it does is it puts the data into categories. Okay. So we can't say one group's better than another group, one major's better than another major. So nominal is the most basic level of measurement, just where you put the data into categories. Okay, so you put the data into categories based on the name. All right, in a high school graduating class of 319 students, Jim ranked 25th, June ranked 19th, Walter ranked 10th, and Julia ranked 1st, or one's the highest rank. Okay, this is called an ordinal level of measurement. Okay, this is an ordinal. Sorry about that. And so in the ordinal level of measurement, ordering the data makes sense. Okay, so it makes sense here. Like we're ordering it by their rank, and these have some meaning here. And so we could tell that, for example, June ranked higher than Jim, Walter ranked higher than June and Jim, and then Julia ranked higher than all three of them. So it puts the data in order, and the ordering does make sense. Okay. However, the numerical differences in the ranks do not have a meaning. So the difference between Tia and Tatum's ranking is 6, and this is the same difference as a lot in Amani's, but like there's not anything significant about it. Okay. And so like basically, for example, uh, Jim and June is 6 spots higher than Jim, but we can't tell. There's a lot of other things there. How much higher is their GPA? If we're looking at GPA, June could have a lot higher GPA than Jim, or it could just be barely higher. So this basically it puts in order from like worst to best, but we can't really compare like June and Jim's GPA. We could say June has a higher GPA than Jim, but we don't know how much higher. So ordinal allows you to put data in order. Okay, body temperatures in degrees Celsius in trout of the Yellowstone River. And so this is what we call the interval level of measurement. Okay, an interval basically allows us to order data, and we could actually have meaningful differences here. Okay, so like we could order you can order the temperatures from highest to lowest or lowest to highest, whatever you want to do. But the problem here is that there's no inherent starting point. So basically, what that means is there's no true zero. And so that's what keeps this from being the highest level measurement, because there's no true zero, because there's no true bottom of temperature, okay? Because it could go, I guess technically it can go forever and ever down. So there's no true bottom there. But we could say that like we can't really say something's twice as hot as something else. I know it seems like you could say that, but that would not be appropriate to say here. So we cannot make what we call the ratio level of measurement, where we can't say something, the ratio between the data. We can't say something like one's twice as hot as another one, because that's not really the correct way to say that when you're talking about temperature. But it allows us to say meaningful differences. It allows us to order the data, but there's no starting point. Okay. Now, the length of trout in the Yellowstone River, this is at the ratio level. And so in this case, do we have a true zero? Yes, because you start at 0 and then you work your way up. And if you had an 18-inch trout and a 6-inch trout, you would say the 18-inch trout's 3 times as large as the 6-inch trout. So we could make meaningful ratio of the trout length. So that is a ratio level measurement. You could order the data, you could take the differences, but you could also find the ratio between the data values.